exclusive open online course aLIFEca Chapter 5, Tools for LCA and Environmental Impact Assessment. Tools for LCA and Environmental Impact Assessment. The complexity of the calculation of the LCA requires support from software tools. This presentation introduces selected life cycle inventory databases and life cycle analysis software tools commonly used in various industries. To help with the LCA analysis, several LCA tools are available in the market which can be purchased or are free. There is a significant difference between the tools in terms of user-friendliness, modeling principles and included databases that can be used. What to consider when selecting LCA software. When selecting an LCA software tool for use in a project, there are several criteria which should be considered in order to select the best option for your needs. First of all, you should identify which needs the tool must fulfill. Do you want to calculate the LCA of a newly created product, or are you evaluating and improving an already established product? Secondly, you should consider if the delivered results are applicable to your conditions. Which software environment do you have available? Will the tool be operated by a single person or multiple persons will share the data? Which type of data is available in the software? Will the tool be used only by your company, or you will share the source and results with others? How does the tool cooperate with other possible tools and system which are you using in your company? How long will the calculations take? Will you be able to use the data and outputs directly for presentation and further evaluation? Does the tool support desired certification? You should also consider the financial side. Does the company already own an LCA tool, or a new tool will be bought? What kind of budget do you have? How many man-hours will it take to learn the tool? It is possible to pay for a course, which will help you in learning the tool. Is there enough examples and adequate documentation about the tool? Last but not least, you should also consider the features which LCA software tools provide. These 5 categories should be considered. Database. The database used for calculation and the methodology is the main element of the tool to consider. There exist multiple databases which are available for one or more LCA software tools. More about LCA datasets will be described later. Uncertainty analysis. Because variation through statistical modeling methods may result in potential distortions, the uncertainty and variability analysis should be incorporated in LCA software tools. Sensitivity analysis. LCA software tools should include sensitivity analysis for studying the robustness of results and their sensitivity to uncertain factors. This step is an essential part of the final interpretation because the input parameter for LCA is often uncertain. Impact assessment methods. LCA tools should include methods used to evaluate potential environmental impacts. 2 prevalent and internationally recognized methods for LCA are the CML 2001 method and Eco-Indicator 99. Presentation. A user-friendly presentation style is a necessity in a good LCA software tool. The results should be presented in a structured hierarchy and allow interactivity with the presented results. This part of the presentation is focused on the introduction of life cycle inventory databases, LCI databases. Life cycle inventory, LCI, database supports various types of sustainability assessments. There are many commercial and free LCI databases that contain information and datasets on one or multiple sectors and can be imported and used by tools. We will focus only on several selected databases in the following part of the presentation. What is a dataset? Dataset describes for a particular product the amounts of created product, byproducts, wastes, emissions to water and air and other used products and resources per unit of product. Thus, when evaluating our product, we can use these existing datasets as a source for the evaluation. Coming back to the database, when selecting a database, we need to focus if the database is well defined and regularly updated, given that technological advances cause the premature aging of the validity of existing data. From the point of view of environmental impact measurement, 2 parameters are critical. 1. The volume, quality, accuracy and relevance of data available to the user in the software, and 2. The software package's user-friendliness. The second biggest concern when selecting a database is to use a regularly extended and updated database reflecting the accuracy and relevance of the data and new technological advances. The third key point when selecting a database is the limitation of the software tool we are using. The best possible solution is to use databases directly supported by the software tool. The first selected database is EcoInvent. EcoInvent database, which is regularly updated and maintained. The database has yearly releases, contains around 18,000 lifecycle datasets covering various sectors, which can be seen on the slide. For example, for the sector fuels, the database contains data on extradition and processing technologies, transportation of crude or refined fuels, production and distribution of most common fuel types, fossils such as hard coal, lignite, petroleum, refined petroleum products and natural gas, renewable fuels such as biogas, biomethane, bioethanol, biodiesel and various solid biofuels from biomass. For the sector of transport, the database contains about 600 datasets covering the production, maintenance and operation of vehicles, the infrastructure and end-of-life treatment. Similarly, for other of the mentioned sectors on the slide, each dataset is attributed to geographical location, state, country or continent. So, when creating an analysis, we can choose the most specific data based on our location. If there is no data for a particular location, EcoInvent contains unique global locations and rest of the world locations representing the global average. The second selected database is Federal LCA Commons. The Federal LCA Commons is a database providing U.S. representative LCA data. The database contains datasets developed by different U.S. government agencies such as the United States Department of Agriculture, USDA, and the Department of Energy and the Environmental Protection Agency, EPA. Moreover, other agencies, such as the National Renewable Energy Laboratory, NREL, National Agriculture Laboratory, NAL, U.S. Forest Service and National Institute of Standards and Technology, NIST, participate in supporting and creating various datasets. The goal of Federal LCA Commons, as stated on their website, is to advance Federal LCA data, research, and information systems by leveraging multi-agency resources and expertise. Improve consistency in LCA methods developed by each agency to develop LCA results for decision-making and public disclosure, and enhance public and agency access to Federal LCA data in a standardized searchable format from a shared repository. The database is free of charge and can be used in different software tools, which we will see later. The third selected database is Carbon Mines. Carbon Mines Chemical Database by Carbon Mines is a large-scale dataset for the environmental assessment of chemicals and plastics. The database is maintained and updated annually and covers over 1,000 products from up to 190 geographical regions. Carbon Mines offer several packages for purchase with a bundle of common chemicals or as data on demand, where you can select particular chemicals and production technologies which suit your needs. The fourth selected database is Gabi. Gabi LCA databases offer around 17,000 processes and plan models based on data collected by Gabi company when working with companies, associations and public bodies. Gabi offers datasets for several sectors, which can be seen on the slide. For example, sector energy processes cover natural gas, power, hard coal, crude oil, lignite mixes from different countries, thermal energy from steam, crude oil, natural gas from several countries and many more. Sector electronics contains 251 processes covering assembly lines, coil, diodes, ICs, PWBs, solder pastes, capacitors, transistors, LED SMDs, resistors, ring core coils, FR4 substrates, thermistors and others. Other databases. There are many other LCI databases that can be used together with the LCA software tool. Many of these databases are sector or geographically focused. For example, the Social Hotspots database provides insight into social hotspots in product supply chains, covering 140 countries and regions and 57 economic sectors. The database includes extensive indicators around labor rights, health and safety, human rights, governance, and community infrastructure. EVA Pigments Database introduces inventory for 51 pigments from various regions comprising 16 different colored inorganic pigments and 10 different colored organic pigments. Half of all inorganic pigments are used in printing, a quarter in architectural paints and the rest to color textiles, plastics, ceramics, enamels, paper, cement, food, cosmetics, pharmaceuticals and automotive products. Let's have a look at the LCA software tools. LCA software tools. To utilize the selected database, you need to work with some LCA software tools. LCA tools help you to search the databases and create a specific analysis for a particular product or product family. SimaPro is one of the leading LCA software tools and has been widely used in the industry and academia for over 25 years. SimaPro can be used for various applications: sustainability reporting, carbon and water footprinting, product design, generating environmental product declarations and determining key performance indicators. SimaPro can be used to easily model and analyze complex life cycles systematically and transparently. Measure the environmental impact of products and services across all life cycle stages. Identify the hotspots in every link of the supply chain, from the extraction of raw materials to manufacturing, distribution, use, and disposal. Sima also offers 2 additional software tools. SimaPro Collect, a web-based tool for LCA data collection from suppliers and other stakeholders via customized surveys, and SimaPro Share is a web-based tool sharing product scenarios with stakeholders. SimaPro includes, by default or on request, many LCI databases such as EcoInvent, Carbon Mines, WeLCI Database, Environmental Footprint Database, Social Hotspots Database, Datamart LCI Package and many others. Gabi Solutions has over 25 years of history in providing tools and consultation in LCA. Gabi Software Suite offers the following tools. Gabi TS is a sustainability solution offering building product plans for the entire life cycle and calculating results that represent environmental impacts according to selected LCI datasets and relevant LCA methods. Gabi TS also offers to compare design scenarios and run what-if analyses to identify the most sustainable and cost-efficient design. Gabi that Envision is an intuitive web application which enables the user to compare different scenarios of the product design by changing model parameters. Gabi that Server supports collaboration between LCA practitioners by providing central database management, quality assurance workflows and user rights management. Users work with the same database and, therefore, can work parallel on the same model. Gabi DFX is software for compliance and sustainable product development with a view to the end-of-life phase. Gabi Software Suite uses previously mentioned LCI databases such as Gabi Database, EcoInvent or Environmental Footprint. OpenLCA is an open-source and free software for sustainability and life cycle assessment which offers several features such as modeling LCA studies compliant with international standards. Data quality system defined by the user or existing ones can be used to visualize data quality and inventory results, the LCA results, impact analysis and Sankey diagram. Automatic and graphical creation of product systems. Uncertainty simulation using Monte Carlo simulation. Many free and commercial LCA databases are available for OpenLCA, for example, EcoInvent, Federal LCA Commons, Carbon Mines CM, Chemicals and many others. Umberto developed by IFU Hamburg, now iPoint, is an LCA software suite with the following software tools. Umberto LCA Plus is a desktop-based software for LCA analysis, which offers a transparent illustration of process chains through clear graphic elements, and hierarchical modeling through subnets. Umberto Efficiency Plus is a software tool focused on resource efficiency and process optimization. Sankey is a data visualization tool that can help in visualizing energy flows, material flows, heat transfer and losses, waste and waste disposal and many other fields of application. Umberto offers integration of several LCI databases, EcoInvent, Chemical and others. Summary. Remember, the complexity of the calculation of the LCA requires support from software tools. This presentation introduced some selected life cycle inventory databases and life cycle analysis software tools commonly used in various industries. There are databases, life cycle inventory, LCI, databases that support various types of sustainability assessments. Many commercial and free LCI databases contain information and datasets on one or multiple sectors and can be imported and used by tools. Several LCA tools are available on the market to help with the LCA analysis, visualization and reporting, which can be purchased or used free of charge. These tools can use one or more available databases.